Very good. Okay, Tom Day. Thank you for coming, Mr. Day. You're a former software engineer. He worked on the Palm Pilot. You all remember that, and has retired now and traveled extensively, been studying about Arctic ice, and is currently living in Santa Clarita with his wife. Tom, we welcome you. And I'm just gonna stop sharing. Look at that nasty picture of ice. Well, that used to be a glacier. Tell us about Arctic ice, and you can just stop sharing. You can share if you want.
I would like to share.
Okay.
Let's see if it works.
Should.
Ta-da. All right. This is a good sign. Well,
Wait.
while you were doing your meeting, I went up the North Pole, checked. It's still there. Things are fine. So this is going to go okay. Here we are at the North Pole. And these are a bunch of tourists. This is what you can do if you wish. They're standing on the ice at the North Pole. And this ice is floating in the water. There's an ocean up there, and it's pretty much covered with ice. And sometimes some places pretty thick, and you can stand around on it. Now, this ice up there, well, let me get rid of this margin. Hello, there we go. Just to step back and get a broad view, the white cap on our planet is made of ice. Some people think of it as our yarmulke. It sits up there and it reflects sunlight back into space. It's right next to Greenland. And this ice is, well, it's not exactly round, and it doesn't stay the same size. In the winter, it grows larger. In the summer, it shrinks down. And March is when it's the largest. September 15th usually is when it's the smallest. And you can see it's quite a difference here. Look at the bottom, Greenland. In March, the whole coastline almost is in ice. But in September, it's pretty much free of ice. Now on the left, you have Alaska and Canada, same thing. At the top, Siberia. In March, it's all frozen in. So this is an annual cycle that's been going on forever. In addition to the annual cycle, there is some change in the ice in the Arctic, and that's from year to year. Now, this is something that's relatively recent, like in the last few centuries. And here are two minimums. Well, this is on the left, the smallest that it got in 1980. And the right, the smallest it got in 2012. Well, you don't need to be a scientist to see these are different. You don't have to measure these and say percentage or whatever. You can just sit back and look at it and say, whoa, the ice is melting. The ice at the North Pole, and it is. You go into the details, and this is exactly what you get. So why do we care about that? Well, the main thing comes to most people's minds first is that if that ice melts, we're going to have sea level rise. And sea level rise is something, well, we're not prepared for. And it could be pretty spectacular. And the funny thing is that the melting ice up at the north is not going to contribute directly to sea level rise. Well, I'm not slipping something by you. Let's go to a time-lapse photography of ice melting. As we look at this glass, we can see there's ice in it. There's a little bit of ice above the water line. And you would think that if all this ice melted, that ice above the water line would spread out evenly across the glass and bring the level of water up. This filmmaker has put in a white line at the left. So to keep us honest, as see what's happened. So let's go from this still over to YouTube. It says when ice melts in a glass of water, time-lapse photography. Right. And how does it do that? How does it do that? It does that by shrinking. Water, when it freezes and turns into ice, expands. And when the ice turns back into water, it shrinks. So all that ice that's melting up there at the North Pole, it's shrinking at the same time that it's melting. And that's why we don't have sea level rise yet. Most of the ice up there is gone, but Miami's still here. Venice, Italy is still here. Venice, California is still here because of that shrinking. Well, there's some more that we should know about ice to understand what's going on. And to do this, we need a thought experiment. First, we need a big block of ice. This one will do. And then we need a warehouse, empty. This one will do. And we put the ice in the warehouse, and above from the ceiling, we're going to hang a heat lamp. That heat lamp is going to shine down directly on the ice. And we go away for a week and come back, and things look like we expected. There's a little puddle of water around the ice. No, we don't touch anything. We go away for several months, a kayaking vacation in New Zealand or whatever. And when we come back, the warehouse looks like this. Where did the ice go? Well, it's no surprise that it melted. We walk over to the place where the ice was, and we scooch down and we touch the floor, and it's warm. Well, yeah, there's a heat lamp directly above it. But think, when did that floor start getting warm? There was a big block of ice, and as long as that ice was there in full or in just the last inch or two, there was ice over the floor, and the floor did not start warming up. When the ice was finally all melted, then the floor started melting. And that's the situation we've got at the North Pole. When the last bit of ice is melted, the floor, in this case, the Arctic Ocean, will start warming. Hasn't started warming yet. Once it warms up, that water will mix with the North Atlantic, which will mix with the South Atlantic and the Pacific, and get down here to the South Pole. Well, here's some more ice. And this ice is quite different than the ice at the North Pole for our purposes, because when the warmth gets down here, this ice melting will raise the sea level. That's because this ice is sitting on a continent, on rock, Antarctica. It's up out of the ocean. And when it melts, the melt goes down into the ocean and raises sea level. Now, how long will it take for that warm water to get down here and melt? Well, we don't know exactly. We've never done this before, but maybe 100 years, maybe 1,000 years. It will take some time for that warmth to get down there and melt, but eventually it will. And so that's in a nutshell, is situation with sea level rise. Hasn't started yet, but the mechanism for it starting. And oh, good. I've gotten my main message across here, and I still have time for some other things. While we're down at the South Pole, let's shift into tourist mode and look at what's down here. Here's a glacier at the South Pole. Those little dots are people. A glacier at the South Pole is something, well, glaciers, they're on mountains, and the ice slides down into the ocean and then pushes on out. About 5 miles away in the background, we've got a mountain covered with ice, and it's all been pushing toward the camera. And finally, we come to a place where it's breaking off. Well, you don't see this at the North Pole at all. You don't have any mountains there, so there's no ice sliding off the mountains. At the South Pole, you got lots of this. And this construction here is called an ice shelf. Pretty novel name, huh? Well, ice shelves have a lot of ice in them, and they eventually break off. Here's what it looks like when there's something breaking off. We're looking straight down here at one of these ice shelves. In that dark triangle at the north, that's open water. And if you follow the dark line along to the right, well, that's open water. So you have this pretty good sized chunk of ice breaking off. Occasionally in our newspapers, we have something like a story. An iceberg the size of Delaware broke off today. And we go, ooh. Well, actually, that happens more or less all the time, but not every day. And now, if it was an iceberg the shape of Delaware, that would be something newsworthy. That hasn't happened yet. Here's the South Pole, Antarctica, and these colored areas are ice shelves. There's several of them. Some of them are quite big. And so you as a tourist have now seen a feature of our planet, you might not have known that before, ice shelves at the South Pole. Beyond the South Pole and the North Pole, there is a third collection of ice that you as a soon-to-be expert on ice on our planet should know about, and that's Greenland. Greenland is an island. And some people have, and right next to it is Iceland. You see it there? And some people have trouble remembering which one is which. And really, it's easy. Iceland is the one all covered in green forest, and Greenland is the one all covered in ice. See, that's easy. Well, Greenland is kind of flat shaped, doesn't have much in the way of mountains. It's just flat, and it's kind of bowl shaped. So around the edges, you have cliffs, pretty good sized cliffs, and then just a shallow bowl, many, many miles across. And it's all filled with ice that builds up year after year as snow falls. It's just, several million years of snowfall, which makes a good layer of ice. So our three big collections of ice on the planet: North Pole, South Pole, and Greenland. Let's take a historical look. You should see 4 labels on these 4 boxes, and maybe if you're given the bottom to zoom, maybe take it back for this slide. 1750, 1950, 2050, and Green New Deal. Back in 1750, beginning of the Industrial Revolution, we had one source of heat shining down on the North Pole, the sun, the yellow sun. By 1950, there were 2 sources of heat. The yellow sun, no change there, and there had been a lot of smoke from steam engines and fossil fuels burned, and so the greenhouse effect meant there was a second source of heat, the greenhouse effect. And so we're going to call this second source lamp Greenie. And that was 1950, and things continued on. And pretty soon, we're going to have melted the North Pole ice. And by 2050, we will have a third source of heat. And that source of heat is the sunshine hitting the open water, the blue water of the Arctic Ocean, and it warming up and then mixing with the world's ocean. So our third lamp is Bluesy, comes from the blue ocean. Some people say, well, wait a minute, we don't want this. It's going to lead to sea level rise and other undesirable. Yes, it will. So what can we do? Most proposals are like the Green New Deal from AOC, some variation of it. The idea being, let's stop emitting carbon dioxide into the atmosphere. Let's just stop doing that or turn it down so it's insignificant. And let's take the carbon dioxide that we've put into the atmosphere out, hide it in a cave somewhere or something, so that this greeny source of heat kind of goes away. That's what all this fuss is about, is policy. Which things can we do that are worth doing? And they're probably all worth doing. Any little bit helps. But we should keep in mind that Bluesy is not affected by this. Once the ice cap is gone, it's gone, and we have that additional source of heat. So there's a large historic view of the ice at the North Pole and climate change. Now, I promised I was going to keep this for a general audience and not have too many graphs. Well, here's one I allow in. This is the population of the world. And over on the left at 1820, it wasn't so much. And by 1950, it was a little larger, but not much. But today, the population of the world is huge. And these people, back in 1950 and today, are heating their houses using fossil fuels and using fossil fuels for transportation. And the problem is not that we're burning too many fossil fuels per person, it's that there's too many of us burning fossil fuels. You might say that this whole climate change problem is a side effect of population explosion. The borders keep coming back. This is on Dropbox. Go away. Now, here's the one other graph in the center of this graph, which is the temperature of the Earth. Temperature of the Earth over 22,000 years. So we're pretty long here. And in the middle, you have a highlighted part, yellow highlighted. And one thing to note there is that the temperature of the Earth, it zigzags up and down, but not very much for that whole long time that's highlighted. We have had, from before the pyramids until today, of not much variation in planetary temperature. Some people hypothesize that because there has not been a lot of variation, we've been able to do things like build pyramids, invent reading and writing, invent the internet, invent Twitter. And that's an interesting armchair speculation. And I bring it up because it's just so fun to think about that. And I'm not going to offer an opinion. So there we are. We had a big block of ice in the oh, my words. In the warehouse. We had a big block of ice in the warehouse. And that's my main message, my main issue, that image that I wish you to take away. Well, I've tried to talk fast to leave time for you to ask questions. And so let's go ahead now and have a questions session. And never mind raising your hand, just if you have a question, speak out. And are there any questions?